Okay, now the second question. So we've already explained the first one. The second one, if the efficiency of the transformer is 80%, okay, and the current in the secondary is 10 amps, calculate the current in the 240 volts supply. Don't forget formula for efficiency: power output over power input times 100%. Okay, now they give us efficiency as 80%. Now, how do we find the power output? Don't forget P is equals to IV. P is equal to IV, and from the formula we have, since we are giving voltage, we have um, secondary voltage over primary voltage equal to primary current over secondary current. Don't forget voltage and current in the transformer have inverse relationship. So when we do that, if we cross multiply, we're going to be having ES IS over EP IP, and that's what we have there, which is equal to 80 over 100. So what do we do from there? We already know that ES over EP is 24 over 240 from the first question, and we'll put that there. We'll have 24 IS over 240 IP equals to 80 over 100. So all we need to do is to put in our secondary current, which is 10 amperes, and we'll do that. We'll make IP our current in the primary coil subject to the formula. We're going to have 1.25 amperes. 1.25 amperes. Now, give two reasons. Question 3, which explain why the efficiency of a transformer cannot be 100%. And the reason is because of energy losses due to number 1, eddy current, number 2, hysteresis loss. I explained that. Constant magnetization of the core, and number 3, power loss due to resistance, P equals to I square R, and number 4, leakage in the coil leakage, or leakage in the magnetic flux of the coil. Okay, quickly, example 7.4. I think there's the last example. We are going to take example 7.4. Example 7.4. So the transformer supplies 15 volts from a 220 volt mains. The transformer takes 0.7 ampere from the mains when used to light 3 lamps connected in parallel, and each rated 15 volts 40 watts. Calculate the efficiency of the transformer and the cost of using it for 24 hours at 30 kobo per kilowatt hour. Alright, quickly. So the first question, we're looking at efficiency. The same formula you get the answer. Power output over power input times 100%. What's our power output? Our power input, we already have, we don't have the current, and P equals to IV. So how do we get the current for power output? Output is our secondary mains. Now, let's get our power output. We know that first of all, since the lamps, we have 3 lamps in parallel, right? 3 lamps in parallel. So the first thing they did was that they calculated the primary power, or the input power, which is IV, and we have the primary current as 0.7. How do we know that the primary current? It is taken from the mains. So 0.7 times our main voltage 220. We have 154 watts. So how do we do our secondary power or output power, which is current in the secondary coil times the voltage in the secondary coil? So we needed to find the current in the secondary coil. So we know that I is equals to P over V, from P equals to IV. Now the current in each lamp is going to be given by 40 amps. How did we get 40 amps? 40 amps. If you check the question, you see that they use 40 over 15. I is equals to power over voltage. So 40 watts over 15 volts, we get 2.67 amps. So since we have 3 lamps, we multiply it by 3. The 3 lamps have no connection to the primary coil. They only have connection to the secondary coil, because that's the one that comes directly to your house, to your lamps, to your gadgets at home. So 3 times 2.67, you have 8 amps. So the output power becomes 8 times 15, which is 120. When you apply the formula for efficiency, 120 over 154 times 100%, you get 78 percentage.